3, 0, 1, 2, so on and so forth. The maximum value for L is n minus 1, and L cannot equal to n. So that's the relationship you need to remember. Okay. Now ML indicates the individual orbital. Like in a house, you have 3 bedrooms, 4 bedrooms, 5 bedrooms. So ML is the number of rooms in that house. Okay. Each room can accommodate up to 2 double occupancy. If you go to a hotel there, and the front desk will tell you the double occupancy per room. I mean, you can put 2 people in the room there. So once you identify the room, the orbital, you can put up to 2 electrons in there. How do you differentiate those 2 electrons? MS, the electron spin quantum number, is going to differentiate those 2 electrons there. But these first 3 quantum numbers, those are the quantum numbers that we use to identify the exact location from the main energy level shell to the subshell to the individual orbital. We need you to understand the relationship among these different quantum numbers. And giving you a set of quantum number, you need to be able to judge whether it's a valid set of quantum number or an invalid set of quantum number. So you have to know their relationship. Okay, so the principal quantum number, again, is the principal energy level. It's a primary factor in determining electron energy. If you have n equals 1 versus n equals 5, electrons on n equals 5 has more energy. Okay, and it's also indicates, based on the quantum theory, also indicates the most probable distance of the electron from the nucleus. So if n equals to 1, if you have 2 different electrons there, one of them has n equals to 1, the other has n equals to 5. Well, the electron with n equals to 1 is closer to the nucleus. The electrons with n equals to 5 is further away. Because they have more energy, they can move in the larger space or further away from the center of the, from the positively charged center. So, but in quantum mechanics there, we're talking about probability. And we would say, well, 90–95% of chance, n equals 1, that electron will be confined within a smaller space, versus n equal to 5, 90–95% of chance, the electrons on n equals to 5 would have a much bigger space, but they are also still confined within that n equals to 5 space. So it gives you the most probable distance of the electron from the nucleus. And it has an integer value going from 1 to infinity. Okay. The angular momentum quantum number, though, angular momentum quantum number, and it gives the subshells. There are different types of subshells in each main energy level. We give them letters. We give them different letters to represent those subshells. So we have S, P, D, or F. If you have to go on further, then G and H. So after S, P, D, it goes back to the alphabet of English language. So F, G, H, I. But we probably will never need to go beyond G or H, because by the time you get to F, you probably have enough rooms to accommodate all of the 118 electrons that we know of. There are 118 elements in the, on the periodic table so far, meaning the maximum number of the electrons is around 118. Okay, so when you have enough rooms to accommodate all of those 118 electrons there, then we don't have to go any further. Okay, so what the L does here is that the angular momentum quantum number, L limits the number of sublevels in a given n because of that relationship last year. Because of that relationship, L equals to maximum value for L is n minus 1. Okay, so for a set number of n, you can only have so many L's. When n equals to 1, L, there's only one possibility, L has to be 0. When n equals to 2, L could be 0, could be 1. There are 2 sublevels there. When n equals to 3, 0, 1, 2, 3 sublevels. When n equals to 4, 0, 1, 2, 3, 4 sublevels. Okay, so L gives you the sublevel, and we have S, P, D, and F, and then limits the number of sublevels in a given n, and it takes an integer value starting from 0, go all the way up to n minus 1. These are the things that we need you to remember, because you've got to know the relationship among the first three quantum numbers so that you can determine where a particular electron is based on the quantum number. Okay, and then if L equal to 0, it represents S sublevel. This correspondence is something that I need you to memorize. Okay. We have S, P, D, and F sublevels. When L equal to 0, it refers to the S sublevel. Okay. The shape of the S sublevel is like a sphere. Okay, so it's a spherical shape. When L equal to 1, it indicates and it designates the P subshell. The shape of that subshell is dumbbell. Okay, and if you go to the gym, you lift weight, you know the shape of dumbbell, two large parts and connected by a handle in between. Okay, so there are two large areas. And so when L equal to 1, we're talking about the next sublevel or subshell, P. Now, let's see, yes, L equal to 2, we're talking about D. L equal to 3, we're talking about F. L equal to 4, I'm talking about G, H, 9, so on and so forth. As you can see, as the L value going up from 0, 1, 2, 3, the shape of those subshells is also getting a little bit more complicated, and there's more areas or more space where the electrons can move around. It only makes sense. And when you have only 2 people there, you can put them in a hotel, you can put them in one hotel room, okay, double occupancy. But if you have 20 people coming in here, you can't pack them all in the same room. You got to distribute them into different rooms there. Now, if you don't have enough rooms on the first floor, and the rest of the guests will have to go to the second floor, third floor, fourth floor, until you have each room with double occupancy there. Okay, so what are the shapes and the spherical shape there? We are talking about probability. So using hydrogen as an example, the most probable distance for the electron in hydrogen atom is about 90 picometers away from the positively charged center. Now, is it absolutely within that? No, not necessarily. We say 90% of the chance. You would be able to find that electron in that spherical shape, confined within it. So most of the time, the electron would be about 90 picometers away from the positively charged center. And 5%, 10% of the time, they may move outside of it. They may be closer to it. But most likely, it's going to be somewhere around 90 picometers away from the positively charged center. So that's what the shape or the radius of each atom is all about. And we're talking about where the electrons are. Now, where do we expect to find them? And we're talking about the probability. Okay, and giving you a diagram representing the different subshells there. S subshell takes the spherical shape. Okay. Whether it's 1s or 2s or 3s or 4s. Well, the difference between 1s and 2s is that 1s is a smaller sphere. 2s takes the spherical shape. It's bigger. 3s is even bigger. Now in 1s, in n equals to 1, there is only one sublevel because when n equals 1, L equals to 1 minus 1, 0. There is only one possible subshell. So there is no other shells, subshells when n equals to 1. But when you get to n equals to 2, L could be 0. L could be 1. Two possibilities. When L equals to 0,